Welcome to Billington Federal CyberByte, sponsored by Cisco. It is my honor to welcome you to this fireside chat between Andy Stewart, the National Security and Government Strategist with Cisco, who will interview Neal Ziring from the National Security Agency, whom Andy will introduce shortly. We thank Andy very much and thank Cisco for their support and for interviewing Neal in this critically important role. Andy?
Thanks, Tom. It's great to be here on Billington CyberBytes with Neal Ziring, Technical Director at NSA's Cybersecurity Division. I'm Andy Stewart, National Security Strategist with Cisco, where we believe that visibility is critical to understanding cybersecurity, whether it be from Cisco Talos intelligence feeds, Snort signatures, NetFlow, or DNS. Collecting telemetry for visibility and supporting detection and response is critical for AI/ML-driven insights, use cases, and contextual learning to help make better security decisions. Today, with Neal, we're going to discuss potential cybersecurity risks to artificial intelligence and machine learning systems, and some thoughts on how to mitigate the potential for an adversary to take advantage of them. Neal, thanks for being here.
Oh, happy to be here. Thanks.
Awesome. Let's just jump right in. Can you provide us a basic overview by what we mean by an AI/ML system?
Well, it's certainly a popular topic these days, but I think it's a good first question because we should establish what it is we're trying to talk about. So when I say that phrase in the context of cybersecurity, I'm talking about any system that includes a component that has to be trained through statistical or symbolic or maybe neuromorphic kind of means in order to do its function. And we'll see as we go through our discussion how that training aspect turns out to be very important to the cybersecurity. And then it may use that function for all sorts of purposes, to guide the actions of a device or system, or to answer questions from humans, or to provide guidance or recommendations. All of those kinds of systems count.
Awesome. Thank you, sir. So what kind of vulnerabilities could these systems have, and how could they could potentially be manipulated by an adversary or a hacker?
So all sorts of ways. The first sort of key aspect to think about is that an attacker might choose to try to intervene or perform a malicious action against these systems at any point in their life cycle, from like the earliest gathering of training data up through all the other stages, and we can hit more of that later. Therefore, you have to think about, can they try to coerce the system into doing something that its owner doesn't want? Or can they acquire some valuable information out of the system that the system owner doesn't want them to have? And then you can break those down into subcategories.
So it seems like one of the potential vulnerabilities could be affecting some of that initial data, as you were discussing.
Yeah, and that's a means to an end, right? A malicious actor might say, hey, I want that AI system to commit some kind of mistake that will maybe benefit the malicious actor. So how could they do that? One way would be to poison the training data so that through various means, so that when the system is confronted with a particular circumstance during operation, it will either fail to recognize a certain condition or classify an image or other data set improperly, giving some advantage to the adversary. Very simple example might be malware. If you have an AI system, maybe it uses machine learning to recognize malware, a malware author might want to say, hey, I don't want my malware recognized by this system. I'm going to attempt to put some data items into the training set that make my malware look like it's innocuous, that it should not be flagged as malware. That would be a very simple example of data poisoning.
It seems like back when I was a data scientist doing research, you looked for many orthogonal data sets. That way you could prevent an attack like that. So in cybersecurity, maybe you could do that with DNS or other information. What are your thoughts on that?
So gaining a good, broad, representative data set is certainly a potential avenue of defense. But unfortunately, it's not a perfect avenue, because if you don't know where those data items are coming from, if you don't track their provenance and their integrity carefully, you could allow inappropriate examples or malicious examples to sneak in. And the mathematics of these systems, depending on what type of model you're using, can be very susceptible to shifts in the way recognition or classification is done based on even a small number of training items. And there's a evolving area of academic research into this that shows different ways that you can approach performing that type of poisoning and hopefully, potentially detecting it, although that's far less mature at this point.
Interesting. Are there any other vulnerabilities that we should be considering?
There are a couple. One that people often forget is the notion of extraction. Okay, so if you're an enterprise or like a government agency, you've put a lot of effort into training your model. Perhaps you used highly sensitive data to train it, like an intelligence organization might do. An attacker might attempt to query your model in a mathematically guided fashion in order to extract facts about the model, its behavior, or the data that was used to train it. And if the data that was used to train it was highly sensitive, proprietary, non-public, you don't want that to happen. So that is another type of attack to which these systems can be vulnerable.
That's fascinating. So securing AI ML is sort of a new challenge for the community. And you mentioned academia. Certainly companies like Cisco and government can come together to address the challenge. Is there a strategic approach that we should be taking together?
Yeah, I think there is, right? This is a fairly new area. The technology that we're attempting to secure is evolving rapidly. So I think there's a role for each of those groups, right? Your kind of classic government agencies like mine, trying to understand the security requirements, the underpinnings, right? The academics performing basic research on these machine learning techniques and their mathematical properties. Industry looking at how they're actually applied in practice and what practical security measures can be employed, or perhaps offering secure services that implement the community requirements that we all come up with together.
Interesting. It seems like we have a lot to learn from each other. So I wonder if a construct sort of like the enduring security framework that's working with, say, 5G might be an interesting construct. Take a look.
Yeah, I think ESF or other, I don't want to be exclusive to them, other industry and government multi-stakeholder organizations are exactly the right place to pursue this. Right, because you're going to get that diversity of viewpoint and the different insights from different stakeholders that can help inform sort of a security consensus. That's what ESF is trying to do with 5G, and I think a similar sort of multi-stakeholder approach will be necessary for securing AI/ML systems.
Interesting. Seems like certainly with 5G, with more data being farther forward at the edge in the MEC, are there additional cybersecurity concerns we should be be thinking about for AI and ML systems specifically?
Yeah, so I think you're right that a whole lot of AI/ML applications will be deployed into our sort of mobile networks, right? Whether it's back in some central cloud or forward in a mobile edge compute installation. That gets back to the part I was talking about earlier of whole life cycle. Right? You can't just pay attention to when you're training your model because you're about to deploy it, perhaps to a highly exposed edge compute installation. Right? You need to think about how do you keep your model up to date and maintained in a secure way if you're deploying it to sort of hundreds or even thousands of devices or forward-facing installations. So that life cycle construct is going to be, in my mind, the sort of the toughest aspect of securing AI/ML, just because there's so much of it to think about.
It's interesting. I think sometimes that's referred to as an AI/ML pipeline, sort of that pipeline where you have different features from collection to synthesis to redeployment and many considerations along the way. what are some helpful steps that would help us mitigate threat, keeping that full chain in mind?
So this is still an evolving area, so I can't give sort of an authoritative or comprehensive set yet, right? We need that multi-stakeholder consensus to emerge. But there are a few things that we know already. The first one is to think about your training and your testing data. How did you come by them? Who was allowed to add to them? Especially in the maintenance of a system, you're going to think about collecting real-world events as your system is used and then feeding them back into the training for continual improvement. How do you secure that, right? You may have got a great individual set, but if your adversary can work things into the feedback loop, then they can over time achieve a poisoning objective. The next bit is to think about, and this relates to the extraction topic I said earlier, think about who's allowed to incur or request inference by your system and get an answer back, right? If an adversary wished to conduct an extraction attack on your system, they'd have to make a bunch of requests of that system. So you want to only allow appropriate authorized parties to make such requests, and perhaps even look at the load, right? If your system normally gets a certain number of requests per day and suddenly it gets 100 times more than that, you might be under attack. So those sorts of issues are just a few of the principles we've come up with so far.
So it really seems like as you consider that AI ML pipeline, you really have some architectural considerations that you have to make before you just speed to deploy.
And practical operational ones too, but you're right. If you're thinking about the architecture of rolling out such a system, you have to take into account, well, how am I going to test it? How am I going to update it? And eventually, how am I going to retire it or decommission it? Yeah, you can't ignore that part of the life cycle because every system is eventually superseded.
Interesting. Are there some non-technical things that we should be considering?
Yeah, there are. I mean, it's a complex topic, but as you're working to, say, secure your AI/ML system, you also need to think about legal and regulatory and ethical considerations. You know, at NSA, which is part of the intelligence community, we have a set of documented AI ethics and governance principles, right? One of those is to make the system secure and resilient, but another one is looking out for bias. And another one after that is making sure that we're utilizing AI in a manner consistent with law and civil liberties. Thinking about those issues and looking at how they can affect how you plan your system, how you gather the data, how you apply the results of inference, are something that both private and public sector organizations need to consider as they're planning to utilize AI/ML technology.
I was going to say, it seems like a whole other rich area for academia, government, and companies to come together on.
Yeah, it is. And there are plenty of academic institutions that are working in this. We have internally at NSA a group that is studying these issues and attempting to tap into that academic research and take as best advantage of it as we can.
Very interesting. So looking forward, is there going to be a day when the AI ML systems can self-eradicate and find their own weaknesses and biases?
Oh, that's a good question. Certainly there's some early research along those lines, using AI to police the AI, so to speak. But I think it'll be a long, long time before we see the AI systems doing this for themselves. I think in the shorter term, what we should be shooting for is a human-machine teaming, where if you have cybersecurity analysts that are attempting to defend or protect an AI system, can they use AI or ML techniques to make their defenses stronger or to detect attacks more effectively? I think that's the benefit we'll get in the short term.
Understood. Neal, any other final thoughts or words?
Yeah, I think I'll go back to that collaborative aspect, right? AI/ML is such a game changer for our economy, society, government, industry. We have the potential to gain huge benefits from it. But if we can't secure it, we may not realize those benefits. So I think it's important for the stakeholders here, both government and industry and academia, to actually put some skin in the game, participate in the debate about how we need to secure and protect and defend these types of technologies, these systems, and then get together and work on it as a community.
Awesome. Really interesting, Neal. Thank you so much for your time and for being here today on Billington.
Thank you. Happy to be here.
Back to you, Tom.
Thanks very much. It's been an honor to have Andy Stewart interview Neal Ziring on this topic of importance for our national security. We appreciate Cisco for making this possible. Thank you for joining us at this episode of the Billington Federal CyberByte, sponsored by Cisco.